So we're going to talk about Java technical stuff, but more commonly we're going to talk about digital music and audio in general. So I'll give you just a little introduction how we get to have those challenges we're solving, where Cosmin dive into the details, and you get the full context. So just to give you a short introduction, I'm Erik, product manager at Adswizz for all things data, analytics, and demand. And I'll let Cosmin introduce himself.
Hi, I am Cosmin. I'm a Java developer at Adswizz. I'll let Erik continue. I'll come back in a few moments.
All right. We're a bit lazy, so I want to start by engaging you and ask a very simple question. Who in this audience is listening to online music? Raise your hand. Only that few? Come on. All right. The idea behind this question is that you most likely encountered our technology by consuming online music. And I want to give you kind of a brief history lecture on how music has evolved. Music, as you all know it, is part of our lives on a daily basis. It just has evolved a little bit compared to like 10 or 20 years ago. If you look at it, it started very simplistic. Everybody had this boombox or this vinyl. Music was very personal and a physical support. You were owning your disc, your cassette, and sharing was a bit of a hassle. Then music became a bit more on the go. You have the great big innovation from Sony was the Walkman. So you could walk around with music in the ears using a cassette player or after that a CD player. And CD was really the golden age of music in the mid of the 90s. And then starts a very interesting trend where we're here today for, is a little thing called internet. And a company called Napster started in the late 90s to allow people to easily share their music, download an unlimited catalog of music. Of course, it was illegal, but the use case was here. People wanted to have access to an unlimited set of music in a very easy way. And the second revolution that started in the early 2000s was actually a little thing called Apple. Apple and their iPod combined with iTunes really got to that stage where you could virtually access any kind of music anywhere in a seamless way. And with the growth of all things, broadband and high-speed internet, we came to become not owner of the music, but more renter. We were tenant on the music. We don't really care about owning the music anymore. We want to access it. And this is where services like Spotify, SoundCloud, or even Deezer came across and say, for a monthly fee, you have unlimited access to all the music, and that's going to be on the go. And if you take that time span, which is around 20 years, that has dramatically changed the way we consume music as consumers. And if you look at it today, we have three main streams to consume music. The first one is on demand. I call it the jukebox of today. You know exactly what you want to listen to. You want to listen to a specific artist, a specific type of music. You just go in there, you type it, and you got it. And those are the services like Spotify, SoundCloud, or even Deezer. The second one is the more traditional way, which still has evolved, is like, I'm lazy, I just want to press play and give me the music. So I know what I'm going to get. So if I tune in on Rock FM, I know they're going to get rock music. If I tune in on Zoo, I know I'm going to get hit music. So that's the linear way of consuming music. And last but not least, it's kind of a hybrid. If you think about it, we call it custom radios, is where it's not really a jukebox. You cannot select the tracks you're going to play with, but you can interact with the service to tell what you like and what you dislike for the service to build up your personal playlist as you go. And those three ways of consuming music, well, have brought new opportunities. So if you think about it, music is now super connected. You can go with your phone, within your car, your Apple TV, of course, at the office, at home, on your computer. So music is super connected. It's easy to share, and it's tailored around you. You can make it your own based on your taste or what you're doing, whatever you're running, cooking. You can get the music that fits that context. And if you pack that together, well, it's an easy way to look at it. Today, I would say nobody is buying CDs anymore. There might be some hipsters buying vinyls, but most of the music is digital. Still, if you look at it, we as users are consuming differently, but there are still artists out there, and publisher, we need to make money. So they're looking for a new way of monetizing our way of consuming music. And then there is the advertisers, which are looking at audio and say, this is interesting, but today I'm super easy to buy audio, video and display. Make it as easy for me to buy audio, and I will buy the digital medium. So all that packed together, well, that creates a huge opportunity for a company like Adswizz to start and help those guys monetize. So, Adswizz in that. Our name is a bit a funny one. Our logo is even funnier. I'm just going to put it out there so we don't have any confusions. We're not an airline. And I say that in a couple of conferences because very often we get, okay, so where do you fly to? How can I be a stewardess or a pilot? Sorry, we have no free tickets or no pilot seats. We are in the business of flying ads, but not airplanes. So what we do? It's rather simple. We are in the middle mix. We are between the brands who want to advertise and access users on a digital platform and the publishers, the platform which are actually providing that music. And what we do for a set of services is that we make sure like a Nike can access users on SoundCloud or Spotify in a very seamless way. And this is a wide range of products. We also do all things around streaming. So our technology is responsible to inserting the audio at the right time so that it doesn't interrupt the stream or the content. We also do all things in terms of understanding what's going on, because if we're blind, we cannot make good judgment calls. So we have all things audience analytics, and here again, things like the Google Analytics for radio. And then, of course, we're doing all the capacity in terms of delivering the ads. So, have to schedule a campaign and target a specific set of users and make sure that your campaign is going to run against those. And then folds that into the media transaction, where we're going to explain today why we have challenges, because the media transaction is really the core of the engine, responsible for making the clever decisions that, okay, this particular ad, where does it best fit? Giving the price, the location, and the user I can see. And before we jump into the more technical solution, just want to put out there the business problem. Today, what are we trying to solve? Well, if you look at it, Adswizz is the leader in terms of digital audio monetization. And we have customers like Spotify, Deezer, you name it. And those guys have a huge audience. Tons of users across the world with different profiles, different way of consuming music. We need to make sense of those guys. And in the other hand, we have a lot of brands and advertisers who wants to access those guys and make sure that they can target the right guy at the right moment. And if you take that all together, it has to happen in real time. And when I say real time, we're talking about a couple of milliseconds. And it was fine when we started, 8 years ago, we had a couple of radio stations, a couple of users, was easy to do. Today, we're dealing with more than 2 to 3 million users connected at the same time on any given platform and requesting ads. And today we're delivering more than 5 billion ads a month and keep growing. And all of that has to happen in real time. So this is why we wanted to talk to you, and I'll give the word to Cosmin about how we solve those problematic, good challenges in a efficient Java cloud. I'll give it to you. Yeah, the phone.
Okay. Hey, so I'm going to go in more tech details about this. Actually, that's not the title we wanted to come up with. The title is this. Does anyone recognize the emoticon there? Oh, nice. I'll give you some candies afterwards. So it's flip the table. It's like when you go rogue mad and you do... Because that's kind of what we did, just to make things scale at the numbers Erik just mentioned. So there is this thing called greenfield. When you start from scratch, you build a new project, you don't have any prior constraints, and everything is cool, you choose the best technologies available, and so on. I'm going to tell you the journey that one of our key components has taken, and we were not in the greenfield. We were actually in the brownfield, which is exactly the opposite. So you have to build on top of something that's really big, that's in production, that runs fine and produces money for your company and pays for your salary. And that key component is called delivery engine. Like Erik mentioned, we need to deliver ads. This is what this component does. So you are connected, listening, and this component figures out that you're a male from Chicago between 30 and 35 and you like BMWs. And will probably give you an ad that's from BMW. And everything must happen in real time. So we have millions of users, and they are connected, they hear a jingle, la la la, and in that moment it's panic on our system because we need to deliver those ads in a couple of milliseconds. It's ideal 10, 20 milliseconds, but we can go all the way to 300 because it's really complicated. And here is what's happening inside our delivery engine. So it's a basic web application, the backend part. First of all, do we have Java developers here or people that program in the JVM world? Cool. So we get the HTTP request, we parse the content, build some domain objects, then we do what we call augmentation, means we enrich the information that we have. And that implies some in-memory stuff like geo-IP detection, and also calling a bunch of microservices which help us understand that you're a male from Chicago between 30 and 35. So that's HTTP. Then we read some data from a cache, then we run some fancy algorithms which are highly CPU bounded, then we run a lot of processes just to get those ads. And processes are very, they come in different shapes, and there can be any combination of them. So we can do in-memory computation, we can call a third party via an HTTP call, or we can go to a microservice, then to the third party. Then microservice, third party, and again microservice. So a lot of HTTP calls. Then we get all these results, these ads, and we run again some fancy algorithm on them to get the ones that pay better for us. And in the end, we build the HTTP response. So what's the problem with that? Our tech stack was basically standard Java EE application with servlets 2.5, deploying in Tomcat, and our problem was that, not working anymore, okay. We had huge response times between 500 milliseconds and 60 seconds. 500 milliseconds is not bad, but it's way above we needed to. We had between 20 and 200 four-core machines which we deployed on AWS. So we are more like a startup, and we can't afford to throw 100K per month on machines on Amazon. We had 700, 1,000 threads per machine, which is a lot. Tons of blocking I/O, like I said, everything was blocking. And we had unpredictable latency. So we had those third-party calls. If one of them was taking like 1.5 seconds, and we had 1,000 requests that were hitting that flow, so all our threads, our infrastructure was blocked, and you had another 10K requests incoming, and everything was piling up and so on, and at some point everything blows up. And you don't like when you get the call at 2 a.m. in the morning, hey, our infrastructure is down. And 700, 1,000 threads per machine, CPUs were mostly idle. So we had like 10% CPU usage because they are doing a lot of context switching. Is everybody familiar with I/O and context switching? Know what they are? Okay. So I/O, input, output, computers take things in, spit things out. And we came up with a solution, our success recipe, and this is what I'm gonna talk to you next. Our success recipe contains non-blocking I/O, asynchronous programming, reactive programming, we used reactive extensions, netty, and a thing called circuit breaker. I'm not going to talk into details about all of this because you can Google it, you can see a lot of tutorials about it, but I'm just going to tell you why we chose them to do. Starting with NIO and async. So there is this buzzword-driven jargon, so-called on some tech blogs, that NIO is the same with async. Actually, they are kind of not, and I'm going to talk to you what starting from blocking I/O. So basically, in the Java IE world, you have this 1-to-1 ratio between your incoming request and the threads allocated for performing those requests, right? So you have your application, you have a request, it being allocated one thread. And let's say you do a database call or you do an HTTP call, and you'll probably do that in a different thread, right? What happens with your original thread? Well, it remains blocked. It's actually not doing anything. It's like in a constant loop, just asking, are we there yet? And this is wrong on so many levels. You should stop wasting resources with blocking I/O and blocking architectures. Your resources are idle, they are not doing anything. And this is where the async stuff comes in handy, and the non-blocking I/O. So for example, for the I/O, the kernel can tell you that your I/O is done, right? So the kernel is like, come on, good guy Greg, here is your result. So you don't have to wait there, you can do other stuff. And this is async. So async is like something on top of non-blocking I/O, and basically you can do something while something else is happening in the background. You don't have to block to wait for something. And what about the number of threads that you can use on your application? So there's no correct answer, but ideally you should strive for something equal to the number of cores or slightly higher, usually 2 times the number of cores. But if you're blocking I/O, and let's say you have 4-core machine, you allocate 8 threads, right? You have 8 incoming requests which are doing database call, for example, and they're all blocking. And that database call takes 1.5 seconds. Well, your 9th, 10th request and so on will probably never get a chance to be taken into consideration. We find out a way where we have a few number of threads and we're doing things non-blocking, right? But asynchronous is not that easy to do. So you have concurrency, you have memory leaks. So let's say you subscribe to an event and you forgot to unsubscribe. And also you have the callback hell. So you know in asynchronous you have those callbacks. Everybody who wrote the JavaScript the HTTP call using Ajax knows about the callback. And if you have a lot of them, you go into the callback hell. There's a website called Callback Hell, you should check it out, it's really cool. And we decided to look at RX. So there's this thing called reactive programming, reactive functional programming, reactor pattern, reactive manifesto, a lot of stuff. I don't fully understand them. But what I know about reactive programming is that you have a processing of asynchronous, non-blocking data flows, data streams. So everything is asynchronous, and basically you are listening to what's going on and you react to those. And we looked at RX. Again, this is just like a teaser. It's from Netflix. We like the Netflix stack and we use it, and I encourage you to have a look at it. They call RX the observer pattern done right, and they pretty nailed it from my opinion. They have this cool thing called observable, which allows you to easily create asynchronous data streams. They allow you to propagate the changes really easy. Concurrency is made easy, and you can listen, right? You can really listen really easy to the events that are happening and react accordingly. So this is our success story. Oh, there were 2 more things, right? I had Netty and Circuit Breaker. Let me tell you about those. So Netty, it's a non-blocking I/O client-server framework. Again, check it out, it's really cool, and it's blazingly fast, and we use Netty because it gives us like 20% gain in performance compared to Tomcat. And also Circuit Breaker. So Circuit Breaker is like you have your box, your machine, which let's say communicates with a microservice via HTTP. You put a 100 millisecond timeout in the communication. Then let's say your microservice is down. So we deploy in the cloud. In the cloud, instances disappear all the time. We have network issues and so on. So they are connected. There is like a circuit formed between them. The circuit is closed. Everything is working fine. But if it fails, your microservice fails, the circuit is open. So it makes no sense for you to make the calls all the time, right? Because you wait 100 milliseconds trying to connect for nothing. Basically, again, wasting time. And this is where the circuit breaker kicks in. So there's this library called Hystrix, again from the Netflix OSS stack, which does this thing for you. So it has a fallback mechanism. It won't call the microservice if it's down. And it, in the background, periodically will check to get a new connection. And if everything works, the circuit is again closed. This is kind of it from the tech side. I didn't have enough time to tell you more. But waiting for your questions. Before that, I said that it's a success story, and here is the proof. This is our response time seen from our load balancer. With red is what we have last year in March. Huge response time, so above 2 seconds. In green is what we have in March this year in production. The first one is the average latency, so 100 milliseconds. And the picture from the down of the page is the 95th percentile Like 95% of our requests are usually in that range. So yeah, for us it worked, and it's really a success story. And you know, flipping the table, now we're chilling down, because I think we managed to put the table back on by using our recipe.
Awesome, thank you very much. I think we have a little bit of time for a few questions. Does anybody have any questions? One at the front here.
Hello. Did you have any particular reasons why you chose Java when you started implementing the new system?
Yeah, because like I said, it was brownfield, it wasn't new. We had to
so
deal
it
with
was
legacy.
already implemented in Java, and
Yeah,
you had to
we had
use
to migrate it. That because otherwise probably we wouldn't have chosen Java. But still, you can do amazing work in Java. Probably would have went with Play framework, Scala, Aka model, something like that. But if you are stuck to Java, if you have the old blocking architecture, you can really do it by transforming it into a non-blocking stuff. Probably you don't have the resources. So the guys from the business won't say, hey, I will give you 1 year to rewrite everything in Scala. No, they say, I have 3 months, I need to make money. So this is where we were.
Okay, thanks.
Any other questions? We've one in the back.
Hi, quick question. You said you're talking with some some other brokers by HTTP requests. My question is, can you improve that communication by stripping off HTTP and just doing raw TCP in the future?
Can you repeat, please?
So instead of HTTP,
Yeah.
which you're doing right now to connect, to talk with other brokers,
Yeah.
strip HTTP, which has an overhead. You
Yeah.
want to have a really low latency.
And go at TCP level.
Go TCP level. Is it
Yeah.
possible?
Yeah, it's possible, but we can't really do it. We are the leaders in the industry, and basically when we're doing those HTTP calls, we're talking to other guys. Those other guys starting developing like 6 years ago, 8, 9, like we did, and they are exposing HTTP APIs. So it's not like we chose to do HTTP, because yeah, we're probably we would have done it at a lower level to not go through the entire stack. But we can't. We are forced to work with what we have. So others expose APIs via HTTP. We are changing the industry with this, but we are the leaders, like I said. So others will follow us. But we have this thing in production for like 3 months. So also the reactive thing, it's not that, I mean, it's popular, it's cool, but not everybody is doing it. But who knows, in 1, 2, 3 years, maybe we'll be there.
Okay, great, thank you.